from a perspective of doing everything in detail, then you understand that 20 days might not be enough. 26, 27 days might be enough, but we have to be realistic if we are mentally prepared to study every day for those 20 days. So it is not possible. So what is possible, we think about it. What is possible, we think about it. And we think about studying in a quicker way. Still, we cannot rush. So we think about studying in a quicker way. Plus, studying maybe gradually more number of hours whenever we study. Yes. We can increase the lecture time. Yes. And we also have to increase revision, practice, and self-study time. Following students. So we have to do this. I'm just waiting for a couple of more students to join who have not yet joined. So I will repeat these instructions again. I want everyone to think about these instructions and just share a few points if you have to share. Otherwise, if you have understood, that's more than good for me. Let's just settle down nicely. Let's just, center our energies, like they say, like shift our focus and everything nicely. And understand that if we are planning for December, so let's target 20th December. They can surprise you with a date of 15th or 16th December as well. But then I think right now planning for 20th December would be enough for us. So I want everyone to again send me a WhatsApp message saying, sir, navigation November 20th. So that I'll understand you are giving this exam, not November, December 20th. So I'll understand this is your exam date. We'll do this till the day we get your exam dates. When we get your exam dates, then you'll send me your actual dates. So you don't need to panic. I'm going to give you all a plan. If you're panicking, understand I am also taking the responsibility. So you're not alone. So you can share your thoughts and your confusions and your doubts and your worries about the same. Right? So I hope I can see some smiling faces. So we are going to cover the other points about the radio wave propagation theory, points that are important with respect to the examination. And then I'm going to give you a brief, what do we say? I'm going to cover all important points about your navigation, radio navigation systems at level 1. Based upon the level 1, going ahead, I'll be covering key points from the level 1 points and explaining them in brief as in short yet detailed. Okay, so that we try to stick to our target and cover all important points, plus create a weightage in terms of scoring marks in the examination. So once again, I ask students, if you have any questions, please let me know. Any doubts? For students who have just joined me right now, what I was talking about in general is that, firstly, if you're preparing for December, then understand we are going to target right now 20th December as your exam date. Okay, 20th December. For some of y'all who wants to clear but you're not prepared, or who thinks they were prepared but now feel we are not prepared. For you, it could be that it could feel like it's less than a month, and that could create a sort of panic in your minds and a sort of lack of confidence also. Some of you all who have already studied 50%, 40%, 30%, you might feel that you are in a better position, or you might feel that you are in a tough spot. Others who have not studied much or don't remember, you'll find yourself in a tough spot. Or you'll just be thinking that, yeah, I'll give attempt maybe at the earliest at January, if not December. Then think about it realistically. Even if you're thinking about January and not December, then the difference between January and December might not be another month. It could be just 20 to 25 days. So think about it and don't impact your pace, right? So the instruction to everyone, I'm just waiting for Mithika. So think about it again. And if you're planning to give this December, then make sure what will help you get it is a few strategies. Those strategies could be increased number of lectures or increased time in the lectures, increased hours of self-study. Okay. And I said one more thing. I'll say that. So this is what we need to do. Just checking with Mithika so that she's also aware about this. So starting today is what I want us to do is have this mindset first, and accordingly schedule right now in your books how much time can you give on a daily basis, and if you're working a job, then how much time can you give on your free days, simple, or the days that you work. Approximately tell me how much do you feel you can do, and also involve your weekends into the same. If I get a majority of involvement saying who is preparing for December, just a second, okay?
Read you one, sir.
Okay, 1 second, students. Okay, good. So think about it, students, and just text me. I think Chaitanya has texted me just now, and Chaitanya has said that he will be giving January. So that gives me a brief idea, and I don't really have to worry much about it. Him with respect to December exam. So whatever personal attention I need to give you all. In that, I'll take more time for someone who's appearing in December. So that will give me more time for someone who's appearing in January when their exam comes, because these students would have cleared. So that workload would be reduced from me, right? Simple. Think
So,
about it before we get started. Yeah, carry on, Hussein.
so can you check my WhatsApp text?
Yeah, I will. I will. Yeah. So that way, we can guarantee that almost everyone is in a better position with more confidence to clear the exam. Students who have not got your computer number today, of course, we cannot give December. So we can say, so January attempt onwards if computer number comes. Simple. At the earliest, that's what we can do. Usaid, remind me again and again in the evening to do that thing for you. You are in line. You are the last one online now. After Gulshan, you are the one for computer number. So let me know. Remind me, okay, just. At least I'll send you instructions in writing, if not on a call.
Roger, sir.
So our studies ahead, even though if we have breaks in the way you attend live lectures, maybe because of your work, and then you are following, then let's assume that you are following, what do we say? Live lectures, maybe yes or maybe not. You should have a sense of continuity towards your progress. Be it December, be it January, or be it February also. Okay. And you see how multitasking it could feel. This is how you will feel, and this is what I want you to enjoy instead of taking in a feeling of burden. Okay. It could be overwhelming. Trust me, it could be overwhelming. And that sense of pressure could impact your learning also. So even if I come up with the best strategy to cover everything nicely, you might still miss out on the intake capability, and that would also leave your learning partial. So that way you might miss on the December attempt only. So what we are trying to do is trying to work so hard and get those qualities within those pending 26, 27 days to make sure if we have an exam on the 20th of December, then we can easily score a 85 on the paper. Okay. Saudi, please copy paste this on WhatsApp.
Affirms.
So we'll get started in a couple of more minutes. Settle down. Don't rush. Nobody's going to rush. I'm not going to rush. But that laid back feeling is not actually a laid back feeling. It's a positive feeling. We are in control and we are doing our best. And there are some things that cannot be forced upon. This is one of those first things, few things that cannot be forced upon. That is your speed of learning at your end. Because you're not just doing it for the exam. I'm reminding it again. You are doing it for the knowledge which you have to retain for the rest of your lives. Right now, you have to retain it till the day of your exams. But the understanding of the knowledge should be there with you. So whenever you'll have next exam, so remember these things, okay? Once you shift your focus, everything that I'll teach, you'll be able to learn. That's it. That way, I'll make sure I cover everything. So when I'm covering everything and you're learning everything, you are covering everything. But along with your live lectures, what I'll need is you following the schedule or my instructions for self-study and revisions. Only then. If you're not able to do it, tell me. Huh? And if you're not doing it, then it's going to be a loss at your end towards the December examination only. Otherwise, you will end up clearing in January if you don't clear in December. So I'm not much worried about your main goals and main timeline much about this session. Because anyone who is unable to clear or give in December, I'll make sure you will clear in January. Whether you are a beginner or whether you're someone who has stopped in between or doesn't remember anything. Okay. So that should help you mentally, because I think today is the first day of beginning of exam forms. So you have time till 1st December to actually make that decision. So every day your decision should contribute towards that, and don't rush into fill in the forms. Save that money, right? And think about your long-term goal also. And of course, your priorities have not got much. Again, some students have sent me. So again, towards the end of the session, your exam dates and your priorities, if you're picking up something else apart from navigation. Do that for the 2 lectures, okay? Yeah, Hussain, tell me.
So Jan would be online demand or the regular?
I'm not sure. I've not seen that in a schedule, so I cannot comment on that. Sorry. The only thing I've recently seen via the schedule is just the for the December regular attempt, the dates. I didn't even read it properly. I've just seen the keywords. Keywords 24th to 1st, and approximate start time is the 3rd and the 4th week of December for all centers. That's all. Sorry, Hussain, but please check with someone else. Or if anyone has this information or a notice, please share with me so I can share that same with Hussain and everyone else. Otherwise, when I get the time, I'll be checking the notification board. Of course, I check it regularly. If I find out, I'll share with you. Maybe always every day before I go to bed, I check it. But for a few days, I have not checked it. I've asked someone else to check it, so they have not reported it back to me. So far, no comments. But of course, we are hoping for a session to happen in January, in my opinion. So it would not be a regular attempt, it would be an on-demand exam, of course. In my opinion, yes.
Sir,
Yes.
so what is the date to fill the examination form for a December attempt
Like I said, 24th November till 1st December.
till 1st December?
1 week
Confirm.
time. 1 week. So wait for it. Don't rush. Wait for it. Because you can only apply once. So if you want to apply for 2 and you only apply once, then you might not get a chance to apply again. And you only apply 3 and you realize 2, then you won't get the money back also. So wait for it. Think. Get in touch with me more and more on these things. We have a couple of days. We have the weekend to connect. After that, from Monday onwards, you can actually start filling in. So generally, your notice for online demand will have keywords like ODL something. There's a code. So the notice that we have is just the one that I have read. Who sent me this message now, students? Please send me your name also. I don't have this number saved. Okay, thank you. That was very prompt. So can anyone help me recollect what are the to-do things? I want to make a list of it right now. And we are going to quickly address them. There is one numerical also.
Sir, that is on that list, MEF, max usable frequency, and super refraction and sub refraction and
Very
dark
good.
wave propagation, and amplifier and plus period.
Sorry, say again. Amplitude and period. Very good.
Yeah.
Very good, Atanu. Anything else in the list?
Effect of ionization.
Say again.
Effect of ionization.
Effect of ionization on frequency and wavelength.
Yes, sir.
Yes. Very good. Very good. Who was this person? I'm not used to your voice.
Victor Tango Sierra Bravo Bravo. Sorry, details.
That was my first. It was not a guess, first instinct, of course. Your name was my first instinct. Students, these days I'm not looking much into the camera, but if you all need more eye contact, just let me know in the message and I'll do that, okay? Because I'm all the time, making sure I don't miss out on any points. So I have just made a small checklist for the same. It's not always that I get to meet that because not always I meet my targets to teach in class, but I don't rush it. Actually, for me, it becomes sort of a backlog in the schedule or the things that I commit to you in a way. But I realize that the class needs time. Students need time. So I compromise on that. So that's the main reason why some of you all might think that I go a little slow. But understand, if your intake and your acknowledgements are fast, then I can actually meet my targets also of points to cover every day. But I don't want to worry, make you all worry about that, because I always have a backup plan. Yesterday, I was just going through all the topics that I want to cover for you all in radio. So I got that sense of, so what I do is I'll see it from an instructor point of view, and then I'll see it from a student point of view. So when I see it from a student point of view, I realize the challenges. If I see it from the instructor point of view, I just realize my duties. So, that's why I say if you need anything else, just let me know and make sure you're mentally prepared about your schedule. And please let me know if you're doing December, then your availability number of hours on a regular basis and weekly basis. Those hours, at least I'll make sure I don't occupy completely through live lectures. So that a bit of that is also available for you for self-study and practice and revision. So I'll rechange my strategy in the class to make sure the length of the class is small, but the quality is still the same. Correct? I hope you're following this. I'm assuming you all are intelligent enough to understand this. And this was sarcasm, okay? Okay. MUF, maximum usable frequency. Effects of ionization. Amplitude, period of EM wave. Students, please help. What is the next point? Someone else now, not the same student, not just Atanu.
Duct wave propagation.
So power,
Super refraction. Victor Tango Gold Sierra November.
maximum usable
propagation.
frequency,
Power. And one more thing I heard, MUF, yes. MUF is maximum usable frequency. And
super refraction, sub refraction,
yeah. Super refraction and sub refraction.
and duct wave propagation.
Yeah, good. Thank you, everyone. So make a list of it. These are the factors. Okay, you cannot see it, right? Students, I've told you so many times to remind me if I'm not recording and if I'm not sharing the screen with you. See, nobody's perfect, right? But yeah, I am dictating, so I always have a backup plan, right? So that's the reason I dictate and want you to listen and write also. One day technology might not work and I might not be able to share the whiteboard with you all. So what? What will we do? Will we stop studying? Not really, right? One student, propagation, refraction, okay? I'll give you the exact spelling again. So there was one student who was from engineering and he wanted to clear his RT. And back then, I was not having this academy. I used to train in any other way. So I met him and he said, sir, I want to join and all. But what we did was we didn't have a place to teach and he used to live somewhere in Thane, Bhiwandi, I guess. It's very far away from where I am or Mumbai is. So he said, sir, we'll meet first. So I remember meeting him at McDonald's near a railway station to save money on the rent because he wanted it at a very lower price. So I thought, okay, how can I offer him scholarship in what ways? By saving money on the rent of the classes and all, we thought we can save more money and reduce his fee. So yeah, we met once. I taught him chart reading and all. I gave him charts and everything, hard copies. And from then onwards, we learned only on a phone call, students. Only on a phone call. And he cleared in his first attempt. And I gave him less time. He always said, sir, I want more time, more time. But I was sticking to my plan and I was confident he'll clear. Now I think he's a technician or something in an airline since a long time. Maybe he's has a promotion also, I'm not sure. But he's there, his photo is there on our digital media pamphlets and all, which will be released. A lot of students' pictures are there who have cleared their RT in the beginning days. So yeah. That's it, students. So we'll be starting in a couple of minutes. These are the points that we'll be covering. So I want you all to take a refresher before we start the points. After Pravachan, I like to take a break before I teach sometimes, so that I'm mentally also aligned with you all and you are mentally aligned. Along with that, if you don't need much of a break in the break time, come sit and revise all the basic points about the EM wave and make sure you don't have any questions. If you have, then send me a picture of those. Once we restart, I'll quickly start discussing all of the points one by one. And then I'll give you time to revise and ask questions. And after that, we'll take another short break and we'll start with our level 1 point coverage of our radio navigation systems. All these things we have to do by 5:15 or 5:30. So let's see how we can do it. So come back, not much, not less, 15 minutes. If you don't need it, take less and revise everything, okay? Welcome back, everyone. I hope everyone is back. So in general, to cover a couple of points from the list of to-do points.
Sir, I think recording is not on.
Yeah. Thank you. I know that. Thank you for reporting. I'm aware. Thank you. Okay, don't worry. It will be posted on YouTube. Okay, don't worry. It is being posted. So yeah, effect of ionization levels. Okay. Now, what is this ionization levels? So we are talking about ionosphere. Students, there are a lot of factors that determine this ionosphere and its different properties. We know one that it begins from approximately 60 kilometers from the surface of the earth to up to what, students? If you can remember, how much? It can go up to 1,500 kilometers, roughly. What is ionization? I told you it is something to do with electrons. In short, ionization means there is an atom over here, okay? An atom. An atom is surrounded by electrons. Electrons, they are negatively charged. Atoms also have positive charged particles known as ions, okay? Atoms have electrons and ions. Electrons are negatively charged. Electrons and ions are positively charged in any atom. At the lower levels of the ionosphere, about 60 kilometers, this is the lower level of the ionosphere. At the lower level, we have a few atoms compared to the higher levels. At 60 kilometers, atmosphere is not there much. So amount of gases, the atoms are not very closely spaced. But when you compare this with the altitude of 1,500 kilometers, then the atoms here are placed more closely compared to the atoms placed on the higher ionospheric levels. So higher levels, if there is any atom, the distance will be more. Lower levels, the distance would be comparatively less. This is not good for flight. Okay, aerodynamics will not work, probably not work, the basic aerodynamics, but some atoms are still there. Now, what happens is a sun is always there to shine on the earth during the daytime. It radiates a lot of solar radiation. Okay, this solar radiation penetrates this slowly and steadily up to the surface of the earth. Harmful aspects of the solar radiation is trapped by the ozone layer and other layers, absorbed and trapped, while the good part of the solar radiation is allowed to come back on the earth or to resume back on the earth. Greenhouse effect is when this earth, this sunlight or the solar radiation falls on the earth and goes back as a reflection, then it heats up the environment. That is greenhouse effect. That is not applicable to ionization though. In ionization, what happens? This solar radiation energizes these ions and separates them from the atom and they go out. So this is the atom here with electrons and with protons. Not protons, sorry, ions. In your textbook, it's ions. So it's going out because of the energy of the solar radiation. Now, you don't know much about particle physics, maybe you know, but this is in your CPL syllabus, okay? This is something that I'm trying to show in a simple language for you to understand. So what will happen? It will have an empty space, and this space is of the ion, which has been gone out because of this. So what happens is atoms have this unique ability to stabilize themselves. So all the time, this atom and this ion will try to merge again and again. And this activity is known as ionization. So the more number of solar radiation from that side, from the above, more number of ions are freed out from the atom, and more number of ions being freed out means more number of activity between the ions and the atoms to merge with each other. So that is instability. Nuclear fission, nuclear explosion is a derivative of this principle of atoms only. Okay, but there you play with the nucleus. Here, nobody's playing with the nucleus, only electrons are being impacted. So whenever you're cooking food, one atom is broken down and the other is broken down, and together they make up a new atom, a new molecule to give you that flavor of that food. So heat, solar radiation, additional energy tend to separate or break an atom into different parts. And if you can control that, then the atom would want to merge with each other again. Or if you just destroy them completely, then burning is one way to destroy an atom completely. Or heating it till that breaking point where it cannot be restored ever again. So here, this is ionization. One thing about ionization, okay? That, okay, ions, if they are free from the atoms, there will be ionization. And this ionization is going to impact my skywave propagation. So what time of the day and night do I have more ionization or less ionization impacts the type of frequency I'm going to use during the day and during the night for HF communication or HF navigation, if I'm using HF for communication or navigation. Super refraction, sub-refraction is something else. But they talk about refraction that can impact to any radio wave along with HF. Now, why only HF is going through skywave, students? Why only HF? Because they can actually penetrate the ionosphere. LF, MF, HF. Now, the other thing about refraction, the actual phenomena that is making you get the skywave, another aspect is to this. Firstly, ionization levels, they can increase at the lower layer of the ionosphere, and they will decrease as you go up and up and up because of the lack of atoms. But this is about the ionospheric ionization levels. So these changes of these layers or the property of ionization is not linear. So you will see that a part of the atmospheric ionospheric layer has a different density of ions. Then the other part has a lower density. Then it has a lower density. So higher density, lower density, and lower density. Now what happens with radio waves, as per the laws of physics and everything, whenever a wave is traveling through layers of different density, and whenever it is entering from higher density to lower density, or maybe from lower density to higher density, then the wave, which I'm making in green, this wave is going to bend away from the normal. Okay, now that normal can actually confuse you in some ways, and one of the lines in your textbooks is very confusing, so I'll make sure you read it multiple times. So if this is my radio wave and this is my transmitter on the earth, if I transmit at this direction, and if this is also the vertical from the transmitter, then the radio waves will be retarded or escape. They will escape the ionosphere. But if I radiate it at an angle, then chances are that it will bend. So generally, the laws of refraction say that first, if a radio wave is traveling from one density layer to another density layer, then it will bend away from the normal. This is away from the normal. So this is the normal. And then after some times, it again goes towards the normal, like this, and it will escape. This is refraction. Okay, this is refraction. Now, another law of ionization tells you that every layer, okay, every layer of ionosphere has more density in the center compared to the lower edge and the outer edge. Now, what is happening? Let's say this is D layer. Let's say this is E layer. Let's say this is F layer. F layer is divided into F1 and F2. Let's say these are these different layers. Although it's one layer, ionosphere, D layer will have different ionization density, E layer will have different ionization density, F layer will have different ionization density. Every layer has more ionization density in the center of it. Focus on this part. Every layer will have more ionization density in the center of it compared to the outside edges of that particular layer. So if I'm talking about D layer now, then D layer will have maximum ionization in the center of it. E layer will have maximum ionization in the center of it. F layer, of course, in the center. F1 will also have in the center of it. F2 will also have in the center of it. Okay. Actual total internal refraction is not to do between the density level changes of delta and echo, layer D or layer E, but it is to do with the center of a particular layer. And generally, we will take refraction only from layer E or layer F. We don't take it from D. Why do we not take it from D? Because in the night time, D layer vanishes. So we call it a diffusing layer also. D layer will only exist during the daytime, students. It will not exist during the night time. So what to do? Can we use D layer for total internal refraction? We cannot, because what will we do at nights? So we discount D layer. We don't use it. So the first layer that will give us total internal refraction, or the first sky wave, returning sky wave called the critical ray, that will come from the first available layer during day and night, which is E, layer E. In layer E, total internal refraction happens because of the levels of density changing in the center compared to the bottom and the top. Okay. So look at your radio wave. So let me make the E layer now so that you can actually see how total internal refraction is happening. Only then will it make sense for us to study the level of ionizations, which are nothing but important points to write down. So the only understanding part is this. Afterwards, just I'll dictate notes, you will write and you'll discuss your doubts. And if you have doubts, I'll show you diagrams. So that makes our job much more easier then. So let's assume, let's say this is the E layer, complete E layer. So this is the central portion, high density. High density. Here I have lower density and lower density. Okay. So if my radio wave travels from low to high, it will deflect away from the normal. Okay. And then it will go back to the normal again. Just focus here. If it is going here, again, it might be refracted and go here like this. So this is not where I'm getting my first sky wave, or this is not where I'm getting any return. What do? This is my Earth. This is my transmitter. Okay. So this is the angle that I have made. I'll check the vertical. I'll check the vertical. This is my vertical of the transmitter. And I'll check this angle. This angle is called, as all of you all know it, critical angle. But is this the critical angle as per the definition? No. Why? Because the wave has not returned back. It's not happening. It's escaping. So this is some angle. So when will I get critical angle? Very simple. You keep increasing this slowly till the time you reach a point where you see that your radio wave is bending completely like this and then coming down. It will happen automatically. All you have to do is just keep increasing this angle of transmission. How will you make sure this happens? You make sure that the radio wave does not reach the center of the layer. If your radio wave reaches the center of the layer, then it's going to be deflected completely. So remember, I'll say this point again. How do I make sure I achieve a total internal refraction? So this is total internal refraction when your radio wave is completely bending away from the normal and returning back to the earth. It occurs at a particular angle. Whatever that angle is achieved is called as a critical angle. And this wave is first sky wave. How do we get this first sky wave? When we keep increasing the transmission angle till a point where the radio wave bends and bends and bends in such a way that it reaches back to the earth. The distance between this is called skip distance. There is a critical angle, there is a skip distance. LF, MF, HF, they all can move via surface waves, which are waves that travel like this. And they can also move via sky waves. The reason we don't use LF, MF for skywave propagation is because half of the time of the day, they are absorbed by the ionosphere. So we can only use it for half of the day. We cannot use it for the next half of the day. So the only possibility is to use HF and satellite communication. Satellite communication, you go to satellite, satellite will go to satellite, satellite will go to satellite and then reach your destination. Only the signals, not the actual satellites. So if I compare a HF skywave, I also have to encounter for surface wave for the same frequency. This point is where it ends or it completely attenuates. So at this point to this definition, this is the point where the surface wave for a particular frequency will completely be attenuated. At the same time, if I'm transmitting that HF frequency as a sky wave, then the range would be nothing but the skip distance. The first sky wave is what I'm looking for. The other day I was saying that there will be more waves, right? Maybe if I increase the critical angle more, I'll get more range. Today you're going to learn actually what is happening. Are we using any more radio waves other than the first sky wave for our purposes? If yes, then why? If no, then why? So the problem is nothing but the problem is in this space where no detectable signal is received for that particular frequency, this range. So no detectable signal means I can call this range as, or this space as dead space. So these are your key parameters to understand the effects of ionization and the effect of frequency on your range and the effect of frequency on skip distance, dead space, critical angle, 10 to 12 important points that are carrying huge weightage when it comes to basic radio wave theory, but very difficult to understand conceptually, but not anymore for you. So the best result you will be getting, or you'll get the best result when you achieve and when you ensure that the radio wave does not reach to the center of that layer exactly. Only then it will completely bend away. If it reaches the center, then it will not bend away. Remember this point, okay? Time to discuss. Any questions?
Negative, sir.
Negative, sir.
You look very tired. Too much
From
of
the point of
information, huh?
transmission to the point of complete alternate point. How did you reach that point?
Yeah, very good. So surface wave of propagation method is such that it slowly starts reducing its energy as the distance increases.
Okay.
So LF and MF, this is just because they don't have much energy. Because there are low frequencies, so they have lower energies. So LF and MF, okay, they have a range formula over sea and over land as 3 into root of power and 2 into root of power. So more the power, more the distance. But as you go away from the power source, that is the transmitter, it will start losing its energy, and there will be one point where it will be completely zeroed down. Generally, we talk about RT receptions at 50%, but this space, it starts or ends where it loses its energy completely, 0%. That is this point we are focused upon. Starting of this point, or the point where the surface wave completely attenuates, to the point of the reception of the first sky wave, or the critical wave, or critical ray. The first sky wave is also called as critical ray. This space is known as dead space, where you get undetectable signals. It means no signals.
Affirm.
Students, for long range propagation, you can also use surface waves, okay? But surface waves, they are actually not reliable. Plus, the equipment for surface wave long distance navigation or long distance propagation is very heavy, and in an aircraft, we cannot use it. Where is this effect important? If you're flying from an airport to an airport where all both the airports are connected by a continuing landmass, which is habitated, as in people live there, then you have no problem using VHF for navigation or communication. But those regions and areas where the area or the space of Earth above which you're going to fly, if that is uninhabited, it's inhabited, not uninhabited. Yeah, uninhabited. It means people don't live there. There's no settlement. And if that is your route, then you have to have something that will give you long distance. And VHF and all will only give you line of sight. So only availability is HF and below. HF, LF, MF, if you can transmit via surface wave, good. Over oceanic regions, yes, surface wave might not be that bad because I have flat oceanic surface. Plus, over sea or ocean, I get more range. Why? Because ocean surface offers more electricity, conductivity. Remember these points. But for navigation, it's not useful mainly because of the lack of energy. And the other thing is because of the weightage of the equipment to be used, not feasible for aviation applications. So HF is our only compromise until satellite communication is 1000% safe. So yeah. Everybody understood this point? Nobody's asking much about this point. When I discovered this point, I was like, I think I'm the only person who actually knows this. So you all might be the only 10% of the whole public in the world who actually knows this. Trust me on that, students. Might be, yeah. If you come across saying, "Nahi, sir, every other person knew," then we would increase 10% to 50%. But I don't think people actually know this. It's not a competition, but it actually makes you feel that you're ahead in line of recruitment or line of exams. I don't know. Plus, it always helps, makes you happy to have all the knowledge that you think you can have, you know. Sordip, you have a question? Go ahead.
Yes, sir. So I was just wondering if during winter season, since um, the layers are a little more compact, will the skip distance reduce?
Of course, there will be an impact of the season. There will be an impact of the daytime, nighttime, and there will be an impact of the level of solar radiation also. Everything. Good question. We'll
Okay.
see the impact. Yes, we'll see the impact.
Okay, so will there be a time where we will not have the dead space because of this?
If your required range is as low as a good range of surface wave, then of course there will not be any dead space. Then of course there will not be dead space. When chances are, let's say you just need this much and your critical angle is this for this transmitter, for this frequency, but your surface wave is giving you the reception already, but sky wave is not giving you. So it could worsen your in a negative favor also. So here, whatever reception I'll get on HF would be actually through the surface wave only. It might be lesser clear. And the only person to be able to receive this as a skywave would be this only, main first person. So I will have a dead space which I don't require in this case. So in this case, also I would not require the critical angle. I could just radiate as a surface wave. That's it. A surface wave would be a directivity only, nothing else. It's just like a gun, you know, in terms of radio. Not a realistic gun, students. Guns that we play in fairs and all. Air guns.
Affirms.
Good point. Very good. You'll know everything that you need to know about these points. Take it easy. Take it slow. Point number 1, we'll write it point-wise. Time of highest ionization levels. Write down shortly after 1400 hours. Shortly after 2 o'clock in the evening, you will have highest ionization levels. Local time. Make sure you write local time. It means for me, Mumbai, 2 o'clock in the afternoon, a little after that, or maybe at 2 o'clock, I can start to say that, okay, maximum ionization is going to happen now. That might not be true for someone who's in the Andamans, although their LMT is same, but their sun activity is very different. But of course, not same for someone who's in Malaysia or maybe different time zone altogether. So write down local time. Okay, local time means your time, not the GMT or other thing, EST or whatever. EST for people in Europe. But there also their actual local time would differ from their EST if the sun is a little away here and there. What is this? Ionization levels. Yeah, spelling. Sorry. Sometimes the mind acts as if the mind is so foolish. Time of highest ionization level shortly after 1400 hours. Local time, that is midday. So any word could come as an option. Be careful. Noon and midday are two different things. So it's not noon, it's midday. Noon is when the sun is exactly overhead. Overhead sun, noon is always 1200 local mean time. So 2 o'clock is generally regarded as midday, they are saying here in the statement. Be careful about it. It's not noon. You might get confused noon with 2 o'clock. Noon is 12 o'clock, afternoon. Such simple questions could come, you know. Point number 2, of course, opposite to this, time of lowest. Gulshan, any guesses? Lowest ionization levels.
Sir,
Midnight.
morning 4 might be.
Morning 4 is somewhere related to navigation and meteorology. Very good. Good guess, but not a correct guess. Think about it. Who can tell me? Hemant, Manan, Atanu? Students, where I have been requesting you all to keep your videos on, I am highly disappointed. Not the ones with privacy issues, okay, who have said that to me. Time of lowest ionization levels. Any more guesses, anyone? Go ahead with the answer.
Sunset and sunrise.
So down and dusk, dawn and dusk.
Let one person finish and then other person should speak, students. Manan, you were saying something?
Sunrise.
Very good. And Atanu, you were saying something?
Sir, I'm saying also that dawn and dusk.
Good guess, but not a correct guess. Time of lowest ionization levels would be just before sunrise, and the sunrise is not the sunrise measured at the ionospheric levels. The sunrise will be different for different altitudes. Okay, remember that. So sunrise for the surface people, that is us. That is the time of lowest ionization level. So generally sunrise can occur anytime between, as per LMTs, what I've seen is anytime from slightly lesser than 6 a.m. till it can go up to 7 a.m. Ideally, the range. Generally, the range is only within 30 minutes in my city, where I have lived more. When I was in different cities, I don't really check the sunrise time. Which season is of highest ionization levels? Any guesses?
So what about after sunset?
What about it? Let's go have some dinner, maybe a restaurant by the sea. You would like that? I would like that. Look at the sunset and the twilight. Let's go. Hussain, where are you? You're in Mumbai, right?
Yes, sir.
Let's study. Let's study by the sea. Yeah, there is something that happens after sunset. We'll talk about it, but it is nothing to do with ionization levels at the moment. But keep an open mind. Which season is of highest ionization levels? Hussain is asking,
Summer.
sir, restaurant to bhej do, kahan hai? Very nice, Hussain. No, I didn't send me anything. Which is, yeah, please go ahead. Who's going ahead? Answer, anyone guesses? Any guesses?
Summer, sir.
Summer.
Summer. Yes. Good guess. Because of increased solar activity, of course. And why do you think you have summer, students? You have summer when the sun is directly overhead your latitude. Okay. That's when you will have summer. So the sun goes from 23 degrees, 23.5 degrees south latitude to 23.5 degree north latitude only, maximum. This is called, this is actually called the equation of time.
Diurnal variation of season.
Yeah, we can also call it the diurnal variation of seasons. This is the maximum declination of the sun actually, 23.5 north to 23.5 south. Declination is the word. DECLINATION. So if you are someone who lives near the equator, then there are sets of months where you will see the sun is majorly on the equator. So it actually travels like this, like an AC current, like an EM wave only. That's why regions above 23 degree half and north, they have majority of winter seasons. Because although they get sunlight when the sun is in the northern hemisphere, 23.5 north, they don't get all of the sun. An interesting fact is they will always get the sun on one side. For us in India, we get the sun overhead, right? Many people in other countries and developed nations, they never get the sun overhead. And if you go on the North Pole, you will never see the sun. One of the poles, you'll never see the sun during one of the phases of the seasons. There are certain latitudes where you'll only see twilight for 6 months. Twilight for
And-
eternity. Yeah,
And I
sorry.
think Iceland is something you never get a sunset.
Something about
You don't see
Iceland.
night.
Something about Iceland. Yes. 6 months of summer, six months of day. Some people have 6 months of night. Not actually day night, but they divide it into day night, of course, but the night is also with sun. Good thing majority of the landmass is around the center, you know. Which season is of the highest summer level, highest ionization levels? Of course, summer. Okay. Now we'll go a little quicker. What should you write next? What do you want to know next, students? Let's see if you can ask me pointed questions, which are a part of my pointed thumb rules.
Season with lowest ionization level.
Of course, season with lowest ionization level. What else? Anything else?
Refraction, more refraction, less diffraction.
Students, when I say highest, we can say that is ionization is higher in summer then winter. Be open to this explanation more. Otherwise, someone will say, what do you mean by highest? They will always think pinpoint it to 1 second, and summer season lasts for 3 to 4 months, or 2 months, or 1 month, depending upon your latitude. So what do you mean? So you say actually it is just higher than winter is what I was trying to say. Now only after happening and recording will I know which was that day which had highest ionization levels. It's something we cannot actually predict much, because you can never really predict solar radiation more than a few ways that it happens. Which season is of lower ionization levels? Then summer, of course. Winter, just for your understanding, need not be written here. Someone spoke about refraction. Okay, I'll tell you about that. What else? Any more questions about refraction? Someone is also asking on chat, what about after sunset? Okay, I'll talk about that also. Any more things you want to know? Demands, come on. On the house, place your orders. No, nothing. I'll tell you. No problem. Make sure these points are thorough in your mind. What about latitude? Okay, so you will say ionization levels. Okay. Increase as option A, latitude increases. Option B, latitude decreases. What will be your answer, students? This is something I've just explained a couple of minutes ago. Ionization levels levels increase as latitude dash. Option A, latitude increases. Option B, latitude decreases. No C option. Manan, go ahead.
Latitude decreases.
Very good. Ionization levels increase as latitude decreases. Example, latitude 0 degree east-west, that is equator, has more ionization at a time than latitude 0 degrees north-south, okay, my bad, then latitude 10 degree north-south. And latitude 45 degree north-south will have lesser, underline lesser, ionization levels than latitude dash. Option A, 55 degree north, south. Option B, 50 degree north, south. Option C, 40 degree north, south. Option D, 35 degree north, south. Confusing options, right? Manan?
D, delta 35 knots.
Anyone else? It's a very confusing set of options. Chaitanya, which option? Bravo or Alpha? Correct your answer. I'm not sure which one to take. Neha, what's your answer? Yukti, where are you, Yukti? What's happening? Make some noise. Suchita, your answer. Jyotsna, your answer. Nandini. Usaid. I'll rephrase the question. latitude 45-degree north south will have lesser ionization levels than latitude, which latitude? I'm not getting many answers. I want everyone to participate. Everyone is telling me delta. What about Charlie? No one with Charlie? Is Charlie not true?
It is true, sir.
So why you're not
C
putting
and D.
that in your answer?
So,
You will say both
Difference is more
C
significant.
and
D.
D. You will say lesser than 40-degree north and much lesser than 35-degree north south. North south here also. Now this is not an exam question, more of a interview question. In exam question, you will either have this option or this option. If you have both correct options, then always go with the most appropriate answer. So both are correct. In this case, the most appropriate, ideally, I'm also filling the blanks thinking about it. Most appropriate answer will be ideally, both are correct actually, but what would the computer take?
D.
It all depends upon what the moderator has done, with the master key. So we don't know if it's a mistake from the person who has got it from the moderator and converted into the digital software, or we don't know if it's a mistake from the moderator end only. So if it's a mistake from the moderator end, then what would be the most appropriate answer is what I'm trying to think. If I'm the moderator, what would I do?
Will take the lesser.
Yeah, I might do the comparison with the least of all. So I think delta would be more appropriate. But I think if it's a typing error, then Charlie would have been more appropriate. So I think I would go with delta in this case, if this was an exam question. This is one main reason why they have reduced the number of options from 4 to 3 in these exams. Because they also have to think about a lot of aspects when they give you a wrong option. Because that wrong option is actually an answer for the commonly wrong ways of solving a sum or the common misunderstandings. So they think about that to make sure that if you're not focused, you might make the mistake, or if you have not learned it correctly, you might make that mistake. So they know which mistakes you will make as a student. So most of the questions are like that. Yeah, good. Okay. So unable to increase the pace yet. Let's see if this happens now. Any questions so far?
negative, sir. Victor Tango Sierra Bravo Bravo.
Negative, sir.
No more questions. Nothing on WhatsApp also. No doubts. Very good. Why would you say that? Because of the intensity of the solar radiation. Okay, remember that. Sun, solar activity only. Higher latitudes will not have as much of sun as the lower latitudes. And this will, north and south will not be true at the same time. Okay. If sometime the sun is in the northern hemisphere, then more ionization will be in the northern hemisphere compared to the southern hemisphere. So the southern hemisphere people will not have ionization when the sun is in the northern hemisphere as much as the northern hemisphere has on the same latitude. Remember that. Okay. So north south I have assumed wherever it is, either at north or south. But don't get confused thinking at the same time, sir, both 50-degree south friend and 50-degree north friend. One is in Iceland, the other is en route to Antarctica. They both are getting same ionization levels. No. Where is the sun? The sun will be in northern. The northern guy is getting more or less. Whatever you are getting is much more lesser than any other northern latitude. Even though you're on the same latitude, but opposite. So don't get confused, okay? I'm just making that distinction. Sixth point you write down, increased solar radiation increases ionization levels. Here you will write note. During intense solar flare activities, it is usual to turn off communication systems using HF and SATCOM, that is satellite communication. Even SATCOM can be impacted. What is this intense solar flare activities? More than usual bursts of energy being radiated out from the sun, more than the normal. So you'll see sometimes due to intense solar activity, we are just not using those systems because they'll cause a lot of disturbance to the signal, nothing else. So you completely switch off, don't give people to even communicate then. It's like that. Okay. Basically, it can also damage. It can damage by disturbing the receiver. If the radio waves catch up more energy than needed, and if that is sent to the receiver might heat up and burst. Not the entire receiver, of course, probably one small resistor somewhere or small resistor that is not designed to sustain more current, or maybe something, any small IC chip, somewhere on the motherboard, something would go wrong. Or a small spark. Sorry, Yukti, if a small spark can also cause short circuit. Yeah, Yukti, you're saying something?
So in poles, there is no solar waves or sun don't come in one of the poles.
Sorry, say
So
again.
the
Radio
communication,
3, say again.
so in poles, there is no solar radiation. So is the communication there difficult because there will be no ionization, anything?
Due to solar radiation, right?
Yeah.
So, what's the question? Are you
So
asking?
is there communication difficult? Is the communication difficult in the poles?
Poles. Poles during intense solar activity or during poles in general during any time of the day and night?
So in general.
In general, no. In general, on the poles, solar radiation is actually close to non-existent. So, impact of this effect of increased solar radiation over poles might not occur as much as it would occur on other places. And this is again because of the declination of the sun. So if this is the Earth, and if I make these tropics are nothing but 23.5 degree north, and the last one is 23.5 degrees south. Second one. So the sun will only move from here till here only, like this. Like this. It means the sun can come from here till here for us. Like this. Generally, we make the sun big, so we are unable to imagine. So it will always be constantly changing its position almost on a daily basis. So even if I assume the sun is here, the light received of the sun in the northern hemisphere is only up to achievable 66.5 degrees generally. We call it the Arctic Circle. And here, 66.5 degrees, we call the Antarctic Circle. So even when the sun is at a maximum declination, that is 23.5 degree north, the sunlight would generally be received here, but this is not reality. The reality is this. My axis, magnetic axis, is tilted. And because the magnetic axis is tilted, my actual equator is this. So my actual Tropic of Cancer is this. My actual Tropic of Capricorn is this. Everyone focus on this, okay? This is for everyone. So the earlier ones were not right. This is the reality for that particular sun. And then I have this 66.5 degree north. And then I have the next one, 66.5 degree south. Now what is happening with respect to this? If this is 23.5 degree north, then my sun will go up to this point maximum. This is the rule of the solar system. Nobody can change it. Good, we have studied it. So the light received will only be up to this point, students, like this. Whatever, wherever it can go. The light received, because the sun is huge, the light received will only be up to this point. But the good thing is, everybody gets to receive light because of the direction of rotation east. But because of the tilt of the Earth's axis, even if I'm rotating, a small part of the cap will never get sunlight. And this is that region, polar region, that I think Yukti is referring to, where we generally don't get light for a long period of time. This is mainly due to the tilt. And that will only happen in one hemisphere at a time, because the lower hemisphere will get it. So right now, the northern hemisphere will get light because the sun is in the northern hemisphere declination. But here, the reception will be a problem. So this is the time when Antarctica will see long tenure of nighttime. Okay. And if the sun comes here, yeah, please go ahead.
So there will be no ionization process in northern hemisphere, no, North Pole, right?
Might not be. Traces of it will be there, but not as much as compared to the other latitudes. The response should be. Never say it's zero. If you have daylight, you will have some ionization. It's just that when you don't have daylight, when you have night, you can assume that there is no ionization.
Okay.
Okay. Point number 7. Everyone in sync, right?
Affirm, sir.
Okay, fine.
Affirm, sir.
Let's write a few more points quickly. Increase in ionization levels is not linear, but in layers. Remember, a simple point. But in discrete layers, I'm giving it to you right from the text, but in discrete layers. The word discrete means very private and very unique compared to each other. Everyone following?
Affirm, sir.
Next point, write down. Ionization is most at center of any layer and decreases towards the lower and upper edges of the layers, and decreases towards the lower and upper edges of the layer. So this is exactly what I was showing you. If this is E layer, then I'll have more ionization and I'll have least and least, and ionization is decreasing. Decreasing as you move out. Simple. Decreases as you go on both sides. Gradually decreases, even though it's one discrete layer. Right now, next point. Very interesting point. Here, put one note. Different layers have different properties. We'll quickly discuss all layers in one quick point or maybe a couple of points. Niner, I want you to write. D layer is lowest at about 75 kilometers. Also, one point, okay? And it exists at about 75 kilometers. Next point. Next point, also called as D region. Why do we call it D by any chance? Any guesses? Because it is a diffuse area. Diffuse. What do you mean by D layer forms at sunrise and disappears at sunset. So students thinking about, sir, something happens after sunset. I've read it. This is what happens. The D layer disappears. The first layer of the ionosphere disappears. Sashank, welcome to the class. Sashank, are you able to understand what's happening? Sashank, you're on mute. Victor Tango Sierra Mike Victor, correction. Victor Tango Sierra Mike Whiskey, Mumbai ground. Sardip, go ahead.
So even if the D layer disappears, still there will be total internal refraction, right? Because of E and F, or will there be no total internal refraction at all?
Firstly, Sardip, we don't use D layer for internal refraction.
Okay.
But during daytime, if for any radio wave refraction is achieved via D layer, then during night time, we can not depend on D layer because it doesn't exist. So E layer can give us refraction, but the critical angle could change. That's why we don't use D layer at all, Sardip. I said that earlier only, I think 30 minutes ago sometime.
Yes. You did.
E and F only.
Yes.
But I hope you've got the answer.
Yeah.
Sure, you might be just confirming, but is there a gap somewhere in our fundamentals?
Negative, sir.
Good. If you feel, you can cross check, cross verify. E layer. E layer is the next layer after D layer. It's like A for apple, V for ball. Huh? Okay. No, I have to tell you, otherwise you'll be confused, students. Trust me, these are points of confusion. I'll never blame you. You might study in rush thinking it's simple, but 1 month, 2 months down the line, you will be confused. So what's the point if your exam is going to happen 1 month down the line, right? What's the point of learning, man? So make sure your notes are so steady that if you read them once, you'll be like, yes, I'm not going to miss any point in the exam. Point as in marks. Each layer is the next layer. Sorry, E layer is the next layer after D layer. Write down average altitude. Average altitude 1 to 5 kilometers. Write down it is present throughout 24 hours. Good, reliable, always there, you know. E layer altitude. Now, this is the very important point because this is the layer of equatorial interrefraction. So something happens to this layer during day and during night. So the diurnal variation, diurnal as in daily variation, is very important to understand about this D layer altitude. E layer altitude. So E layer altitude reduces, underline reduces at sunrise E layer increases in altitude. I'm just giving you two different languages for the same point. Question could come in a different language also, or the textbook language also. E layer increases in altitude after sunset. This point is a point of confusion because generally we associate sunrise with more ionization, and somewhere in the subconscious, we think that more ionization means higher layer. That's the general brain picking it up automatically if you're not careful about it. So to avoid that, make sure you know after sunset, the A layer increases in altitude. We are not talking about ionization. So that's the way to think about it. Are we talking about ionization? No. If it would have been ionization, we would have said reduced during night after sunset. Okay, good. D layer disappeared after sunset. Good. E layer ionization we are not talking about. What we are talking about is altitude. So the example would be day and night, E layer. Okay, I'm only showing E layer. I can say (120 kilometers), just an example, okay? And I'd say, let's take today. What is today? 24/11. Same day, 24/11 night, of course, evening and night. My E layer is going up. And why is it more, Baba? Yeah, fine. I would say it would go and increase up to 130 kilometers. So I'm getting an average of 125. That's how I figured these examples for you. Okay, same, nothing else. If you want to talk about something else, then you can talk about D layer. D layer exists. Do I have to show D layer doesn't exist there? How do I show it? I can just say that no D layer exists as it disappears after sunset. Similar diagrams can be made for comparison between winter and summer. Any more points about E layer? Think. Write down the next point. Chaitanya, I hope everything's fine at your end. Hemant.
Yes, sir.
Shashank, you just have to get used to things. Don't worry.
Yes, sir.
Very happy to see you. Sordip, I hope you have arranged for a comfortable setup to study. Yukti, I hope you're keeping well and studying.
Yes, sir.
Manan, I have seen you, but I've not seen you working, so I'm not sure. Chaitanya, I've also not seen you working much. Hemant also. Saurdeep is discussing, so I can understand, maybe not. But Saurdeep, I'm a little worried if you are distracted every now and then, Saurdeep, and I cannot see you also. So I'm a little concerned about that. Do let me know after the session if you have any distractions. And yeah, everyone else I can see. Good. Next point. I told you all I'll give you another break. That was subject to we finishing this. So we are not finishing this. So sorry, we are not doing the break. Finishing this part before radio navigation. Okay. But it's okay. I think you're getting it. These are difficult things to understand. Next layer you will write down is F layer. F layer is the next layer of significance after E layer. Write down the altitude, average altitude for E layer as 225 kilometers. Two to 5 kilometers. Do you remember I told you all that the lower layer of the ionosphere will have the maximum ionization? That lower layer of the ionosphere is into discrete layers those are D layer, E layer, and F layer. So from 60, we can say about 75, we are getting a good layer, but that is not dependable because that layer never shows up after sunset. After that, we have echo, and after that, we have foxtrot, E and F. But F, we see it is going up to an average altitude of 225 only. While the actual ionosphere, we are saying, goes up to 1500 kilometers, 1500 kilometers, almost half of the Earth. 3/4, I would say, 3/4 of the half of the Earth. So, yes. So these all layers are actually the lower layers in combination compared to the actual ionospheric layer. Remember that. So 225 kilometers will be helpful to remember if you compare the ionospheric highest levels to be 1500 kilometers. Be very careful with these words because the only challenge in the end in the examination would be the complexity of the language of the questions. The questions can be difficult to understand. It can happen with the best of you and with the best of me also. Okay, good. Do you think F layer is important? F layer splits into two layers, that is F1 and F2 at sunrise. So during day, you will have F1 and F2 after layer E. Okay, that is the meaning. F1 and F2 rejoin into F layer at sunset. So during daytime, F1, F2. During nighttime, F only. So during night, we only have E and F. During day, we have a lot of people, a lot of identities, D, E, F1, F2. During night, only two people, two are left. It's like night shift, manpower is reduced. That generally happens in companies, okay? Not with Indian companies catering to Australia and America, of course. F1 and F2 rejoin into F layer at sunset. Right about the altitude of F layer, F layer reduces in altitude at sunrise. And F layer altitude increases at sunset. Same funda, students. Same fundamental. Just giving an example, make sure you're thorough with these points and the time invested is worth it. So this is what is happening. Daytime, F layer is decreasing in altitude, but has two parts, F1 and F2. During nighttime, F layer is increasing in altitude, but the F layer has merged back into one. Don't worry about the intensity levels. So that band looks small and the band looks thicker and thinner. Ignore that thickness and thinness right now. So if I have to complete this diagram, then I get E layer here and E layer slightly above. So my E layer during daytime, I was assuming 120 kilometers. During nighttime, I'm assuming the D layer 130 kilometers higher. And let's talk about D layer. So D layer, I know 75 kilometers. D layer exists, while here I can simply write D layer disappeared. Now this gives me an overall understanding of day and night also, all the different layers also, and the theory behind them. Point number 12, okay. Wait. Write an important note about F layer. Behavior of F layer is affected or dependent on the time of the year. Time of the year as in season, students. That is, in bracket, right? Seasons. There's a slight difference between climate and seasons, okay? Seasons are predictable features of the atmosphere, I could say, in different regions. Generally, when we calculate seasons with respect to your navigation studies, the seasons are defined with respect to the northern hemisphere in mind. Because same seasons will not exist everywhere on the earth. Monsoon in India is predictable, but monsoon in other parts of the world is not predictable. Monsoon exists for everyone, but India is lucky we can predict monsoon. India is very lucky because it has everything. It has ice, it has desert, it has rainforests, it has beaches, it has everything. It has everything in the world that the world has to offer. A good thing that it is also developing. So one day we'll be like all the developed nations, be it desert nations or ice cap nations or jungle nations or, okay, seaside are not nations but cities. So overall, I think future in India is good. Behavior of F layer is affected on this is not on, okay, this is or dependent on the time of the year, that is season. So write down what happens to the F layer in summer and then write down what happens to the F layer in winter. Write down the F layer increases in altitude in summer. In summer, F layer altitude increases and can go above 400 kilometers also. In winter, F layer reduces in altitude. Today it's getting so difficult to even, sit still. This was point number 11, right? Now write down point number 12. Effects of ionization. Effects of ionization or levels of ionization increase from sunrise to midday. This is the reason why just after midday, you have the maximum ionization levels. The lag is due to what we call as a delay in the sensing of the temperatures. When you learn temperature, you realize the cause for the temperature increase and the increase in temperature, they are not instant. You learn all that in either solar system or time. So effects of ionization or levels of ionization increase from sunrise to midday. Very important thing to know. It can be missed out from your minds. Okay. Levels are constantly fluctuating with the fluctuation of the intensity of solar flare radiation. Okay. Thus, making it possible for ionization levels, to decrease temporarily during morning, or increase temporarily during afternoon. That is, in bracket, right, post midday towards sunset. So there might be possibilities that sometimes during morning you will have low ionization compared to during evening. That would only happen due to fluctuations in the solar flare radiation, nothing else. Take a minute or two, go through everything. We are not done yet, but as we are approaching the 5 o'clock, 17th hour of the day, our mindset could change. So let's slow down a little bit. Generally, instructors tend to teach more towards the end of the class, and the students are tending to receive more towards the end of the class. So that could also impact everything, you know. So let's just slow down nicely and learn a little less towards the end. A new thing in our strategy, so that we learn completely and we don't have any open-ended questions in our mind. Point number 13. Ionosphere structure can be said to give us stable conditions during day and night. So what they're trying to say by this definition or this sentence is that at least during the whole of the day, you will get almost stable conditions. So the ionization levels more or less will be towards the similar level of intensity. So during a day or night time, there will not be much fluctuations. Of course, the solar radiation can impact the level of intensity temporarily. Why temporarily? Because the solar flares will not be permanent. They'll just come and go. Come and be done with. They will not go elsewhere. That's good for us, you know. But around dawn, so Atanu was saying something related to this. So people here and there who have learned earlier know some key points here and there. Now, master it. Know it for what it is. You are no more in the land of uncertainty. So, but around dawn, that is sunrise and before, and at around dusk, that is sunset and before, and a little bit of after also, you can say, subject to you have read the definition of dawn and dusk. They are not discussed in navigation, the definitions of dawn and dusk. So I'm giving it to you for our understanding only. Not just sunrise, pre-sunrise, post-sunrise, a little phase, we can say it's dawn. Pre-sunset, post-sunset, a little phase, we can say dawn, dusk. If you know the exact definition, share. I'll share with the class if I find it correct. Dawn could mean beginning of the sunrise till sunrise, and dusk could mean beginning of the sunset and then sunset maybe. Whatever the thin line is, this is the actual meaning. A little before and after. I've not yet got the actual definition. No problem. Not important. But around dawn and dusk is the key word. You can say around sunrise and around sunset. The structure of ionosphere is in a state of transition. That is change. Now you know why aircraft stops are also called transit checks, because the aircraft is under change from one flight to other flight. So the transit word actually comes from transition, nothing else. So you change the pilots, you change the staff, you change every crew, change the passengers also sometimes. The same passenger is seated in one plane. Sometimes, most of the times these days, I've seen a lot of cabin crews also staying in the same plane because some people are late. But pilots generally are not required to stay back because a backup pilot is there. Anyway, so transition. So when does transition happen? Dusk and dawn. So write this important time. These times are those of maximum interference to ionization levels and their practical applications with skyways and satellites. For us, main is skywave over here. This is called electrical interference. So as a pilot, you should be aware that during the time of dawn and dusk, there'll be more electrical interference in the ionospheres, in the layers of ionosphere. That interference is not going to help me. All stations, how do you read?
Radio 5.
Radio 5,
Radio
sir.
Victor Tango Charlie Hotel Alpha.
Okay. Victor Tango November Echo Hotel 1 2 3 4 5 5 4 3 2 1. How do you read? So electrical interference is nothing but the layers transitioning. Electrical interference will be nothing but the layers transitioning from what they are in the day to what they are in the night, or what they are in the night to what they are in the day. This transition is nothing but electrical disturbance. There's something extra that you're learning today, or electrical interference. Victor Tango November Echo Alpha, how do you read? Neha, you are on mute. Okay, if you're replying. This causes the radio navigation and communication systems using ionosphere to have excessive disruption and interference. So many a times you'll come across a time of dusk or dawn when you might face certain more than average or more than normal errors in your VHF comms. And if you're using ionosphere like SATCOMs or satellite navigation, and if that is located in your ionosphere, the orbital distance from the surface, then of course, you should know why. Because the layers are just shifting from not being D to being D and being F to being F1 and F2, reducing and increasing and decreasing altitudes. Actually, if you look at all the layers together, then daytime, all the layers will be lower. Nighttime, all the layers will be higher. It's just that D is not there, F is there, F1, F2 is there, whatever the combination is. Neha, are you able to hear me well now?
Affirm, sir. Thank you.
So just these points. Did you cover these points? Point number 13?
Negative.
Point number 12 done?
12 done.
Okay, so students, I'm going to revisit point number 13 for everyone. Ionosphere structure is said to give us stable conditions during day and night. Apart from unpredictable solar radiation, daytime will have a good stability in whatever layers I have, D layer, E layer, F1, F2. Nighttime I'll have good stability, whatever layers I have, F, E and F merging together. Okay. But during dawn and dusk, during the process of sunrise and sunset, the ionosphere structure is changing from day structure to night structure or night structure to day structure, where one layer disappears or reappears, and where F is either splitting into two or merging into one. So that phase is known as a phase of transition. And that transition causes a lot of problems to ionization levels and their practical applications with skywave and satellites. The problem is nothing but termed as electrical interference. So electrical interference, if someone asks you, when do you face it more? Don't say, sir, during thunderstorms. Don't say, sir, during intense solar activities. Don't just say those two things as your answer. So say during dawn and dusk also. But the electrical interference will only be to navigation and communication systems using ionosphere, not the ones using VHF and above. So this should be your answer. So as a pilot, you should be aware if you're using ionosphere for HF comms, and if you are using any satellite-based communication system or navigation system, and if that satellite is somewhere in the altitude between 60 kilometers to 225 kilometers, or maybe at times 400, and HF wave, of course, we know HF will come back from E or F. Then during dawn and dusk, you'll face interference. So be aware about it and don't take decisions. Be careful. Check with ATC. Keep communicating. Wait for the time to change. Of course, time will change. Good thing about this is that this error will be over. And then after sunrise is there, yeah, good. So that's why you will see frequencies used during day and night for HF comms are different. This is the reason. The reason is because of the layer we are using for refraction. In order to not make the frequency change much, during daytime we use E layer for refraction. During nighttime we can use F layer for refraction also, in order to make sure we want to use similar frequencies at similar critical angles. That way also I can manipulate, many ways to manipulate this. This is it. Right on the next point. So I think Neha, you missed only this much. Anyone else missed anything about these points? No compromise here, students. Go through every point.
So,
Mm-hmm.
sir, can you please show me this 12th point?
Mm-hmm. Yes, sure. Here. Effects of ionization or levels of ionization increase from sunrise to midday. A very important point. Levels are constantly fluctuating with the fluctuation of intensity of solar flare radiation. Levels of what? Levels of ionization, not the altitude here. Levels of ionization are constantly fluctuating with the fluctuation of intensity of solar flare radiation, thus making it possible for ionization levels to decrease temporarily during morning. Generally in morning and after sunrise, we expect high ionization levels up to midday, right? But sometimes we can have lower ionization levels just because the solar activity or solar flare radiation is fluctuating from the normal way it behaves. That is the meaning. Got it, Yukti?
Affirm, sir.
The keyword is it will temporarily increase during afternoon. So a student might think it's obvious, but afternoon means they're trying to say after 2, but here by afternoon, they're trying to say after midday, after 2 o'clock, that is. That is their way. So someone who drafted these notes was not aware. These notes come from the best textbooks, so those could be repeated in your question paper. So I have to use those terms, okay? So those were not really concerned about student confusing themselves with afternoon and midday. But the difference here, it can go afternoon, but it would generally mean after 2 o'clock, not after 12 o'clock. Okay? Whew. Anything else, students? Think about it. Fourteen point about total internal refraction. It is related to this, not exactly the layers. Okay, write down this point. for any layer, ionization levels increase towards the center of the layer as radio wave transits. Here, transit means passing through. So another word for transit is we are passing through this particular airport to our next destination. Here, as radio wave transits through a layer, it passes from lower part of layer with lower density to the central part of higher density. This density encountered is further lowered as radio wave transits out of center towards the higher part of the layer. I've already explained it, so don't worry. I know this will make easy sense when you're reading it, but I have to give you these points in writing to ensure you don't forget them. Okay?
So, could you scroll a little up? So,
tell me what to read back. I'll also read back. Okay? Total internal refraction is total internal refraction. Yeah, please go ahead, Sardeep.
So, you have missed central part of the layer with higher. So, the central part of the layer with higher.
Out of center. Yeah, fine. Okay. Central part of layer towards the high part of the layer.
No, on top. So, not this one. Not this one. On top.
So the center of layer, right?
Yes, and central part of the layer with higher density.
Here, this one.
Middle, yes, sir. Yeah, yes.
खुद confused हो यार Sardeep?
नहीं सर, मैं आपका वो wordings follow कर रहा था आप जब बात कर रहे थे.
Never say yes in a flowing river, huh? There's a Hindi quote, right? हाँ में हाँ कभी नहीं मिलाना when it comes to navigation. Don't compromise. Okay. It's okay. It means the same thing here. To the central part of higher density means central part of the layer only, students. Come on. It's understood. You can write there as a arrow if you want. If it confuses you, central part of the layer with higher density, you can write that. Or central part of higher density means the central part has higher density. Nothing, it's just Indianism. Indianism can give 10 variants to a normal English language, you know, maybe more. I think 130 crore people, so 130 crore variations in the way we speak English. Any more doubts? Write down. And then radio wave moves out of the layer. Okay. The next point is very important, but you already know this. Write it down. if radio waves are at right angles to the layer, they will be retarded, but will maintain a straight path. At right angles, retarded, but with a straight path. Example, this is the right angle to that particular point in radial. So this will be retarded, like escape, or retarded in a way, but will follow a straight path like this. They're talking about layers within a layer over here. Okay. Of course, a little bit of refraction would happen, but let's stick to these points right now. Next point. Same point what I had said in the opening part of description. Write down at other angles, radio waves will be refracted away from their normal, passing from low to high, that is low to center, and then bend back towards normal, passing from high to low density, that is center to higher layer. Okay, so now you understand the density relationship with refraction without having learned it directly. When a wave travels from a layer of low to high, when it exchanges its mediums, not exchange, when it changes its medium of travel, the wave tends to deviate towards the normal if the change in density is high, low to high away. But if the change in density is high to low, then it goes back towards the normal. So this is my point of confusion that I had for many years, since after the first time I learned this concept in school. And when I realized I have to learn this in aviation, I knew that somewhere in the base of my mind, I'm still confused. And no matter how many textbooks I read, nowhere in aviation textbooks it's clearly mentioned what refraction is. Their language is very confusing, and I see different things mentioned in different textbooks. So what to do with aviation perspective? Then you pick it up from experience, nothing else. Okay. Now, of course, there will be an angle at which we'll come back or we'll get it back. Okay. And then they exit the layer. So this is still not total internal refraction. Otherwise, a lazy student like me will stop here. Okay, now I know what is total internal refraction. But then in the exam, I would be the same lazy yet overconfident student who is now a confused student. I'm like, oh my God, what am I missing? And then I'll come back and I'll be like, tough paper. Any doubts? Easy to understand? Very good. That tells me that the first part of the lecture, you were actually listening. Very good. About total internal refraction only, continue writing. amount of refraction is based upon number one, frequency, and number two, ionization. Students generally think that, sir, the layer of atmosphere or the layer of ionosphere is also going to be a determining factor. In a way, you are right. Okay. But the layers, we are not using the layer for layer. We are using the layers as per their ionization levels. So during day, we use E, during night, we use F, because we are getting that optimum ionization level that we need, respectively, either from E during the day or F during the night. So I can say ionization is the determining factor, not the layers. Got it, students? So that's how you can get confused even by when you are right, but the language and the specific aspect of the moderator that he or she needs to ask could be different. And such questions will be picked more often than the easier questions to give you in your exams. So the question key point is amount of refraction, not the range, not the range of HF or VHF or sky wave or surface wave or any other satellite. So the keywords you have to focus upon. Amount of refraction, okay, frequency and ionization. So earlier, up to the earlier point, I'm talking about some refraction where the radio wave is still escaping as they exit. So only if I had more refraction, I could, try to get it back. More refraction at the first point of bend only, somewhere in the central layer. So how do I make sure I get optimum refraction or more refraction? You use the right frequency or you use the right ionization levels for that frequency. Okay, I have this frequency I want to use because my transmitter receiver have been designed to that frequency. I'll be like, okay, for this frequency, you'll get good ionization levels at about, E layer during the day, but during the night, probably F layer would give you better refraction. Okay. So frequency is constant. I can change the ionization levels by selecting the different layers, not the altitude of the same layer. This is the second subconscious mistake we end up making. Or if I want to use the same layer, then chances are I'll have to change the frequencies during day and night, of course. Chances are E and F could still be changed and frequency could still be changed. And that is actually what happens. It's a combined mutual agreement of rejection and acceptance, we could say, with respect to what we are using when we are using these frequencies of HF skywave propagation. So this is your major point. The final conclusion that we are writing in writing, or we are learning in writing. If the radio wave refracts to the Earth's surface, if the radio wave refracts back to the Earth surface, we'll come to that point again, students. Write down one key point. Earth horizontal, okay? If this is your layer, okay, this is your land, this is your transmitter, whichever layer, okay? We know the central part of the layer is more ionized, so I'm making it dark here. Okay, it's just any one layer. Let's assume E layer. So I have one vertical that is normal. Okay. This vertical is with respect to antenna. If I have a radio wave, then this line becomes the normal also of my radio wave. Okay. And at any point for my radio wave, there will be a related physical counterpart that is horizontal in nature anywhere. I can take it anywhere, and this becomes the Earth horizontal with respect to that radio wave at this particular point, or maybe at this particular point. Take any point. Because the curvature is so high, at any small length, you can always find a straight line. Now, what are they saying with respect to this? All are Earth horizontal with respect to this radio wave. Now, what are they saying? And what I said earlier is what I'll repeat. If the radio wave can start to bend towards the Earth horizontal before it reaches the center of the E layer, this is the main criteria to get total internal refraction, students. If it gets into the E layer, students, it's not gonna refract in the way we want to, because that layer will not have much of transition for the refraction to happen. Because in the center, it will have max. And then as the radio wave will go out, it will start reducing. So from high density to low density, it is going to bend towards the normal again. So your target is to ensure it is capped below the center, which is actually the highest density, so that as long as you're traveling here, up to here, you will keep refracting away from the normal because you're still going from low to high. If you reach highest, you might think, sir, I reach highest, I'll get better refraction. But the moment you reach highest, instantly you move a little ahead before refraction, you'll start going lowest. Lower, not lowest, but lower will start. And that lower starting will always bend it towards the normal again. And it will escape. Okay. So if you can ensure that the refraction is such that it bends towards the Earth horizontal before it reaches the center of a layer, that is your critical ray actually. So please complete this point now with respect to Earth horizontal. Only if the radio wave, refracts or begins to refract towards Earth horizontal, that is, in bracket you will write, away from its normal. So in other words, it means away from its normal. Okay. Only if the radio wave refracts or begins to refract towards Earth horizontal, that is away from its normal, before it reaches the center of the layer, then it will continue bending or refracting then it will continue bending or refracting and will return to the surface of the earth. As the skywave or as a skywave. This is the total internal refraction at the layer. If I speak some more, I think I'm gonna collapse. Of course not, but this is how I'm feeling right now. So I think we should stop what I'm doing and let's give you some chance to speak, discuss, share some points, revise, ask some questions. Cover all important 14 points so far. Go through all 14 points. See if you have understood. Anywhere my handwriting you cannot understand, check it, cross-check it. Any words you have circled here and there, God knows what sir said, he's so fast, or I don't understand his writing, I'll go through the lecture again on YouTube. You can ask now only, students. Verify those things at least. I'll get to verify it on the notes also. Earth horizontal. For this also in this diagram, we can say this is Earth horizontal.
Can you please show me the 13th point?
Yes, yes.
Okay.
Here I've written and after. Before and after, just in case. A little bit here and there, dawn and dusk. I'll just look up exact definition of dawn until then. I was hoping someone will send it, but I like how you're focused here only.
A little down, sir.
Yeah, sure.
Thank you.
So generally, I think dawn is the beginning of sunrise. So the first light, the twilight, till sunrise is dawn. Once the sun has risen, afterwards you don't have dawn, but you still have twilight. So don't write after. And dusk is, I think, up to the point where the twilight after sunset ends. Let's see if that is true. Generally, dusk is defined as the period of partial darkness between day and night. It is the part of twilight, evening twilight. Twilight is that very pleasant light, orange, purple. There's so many shades to that light. I enjoy that time of the morning and evening very much. And right now I can see from the east that shade is starting to arise. So on my left is a unobstructed view, you know. This also gets amber, kind of a very good shade, and the other side also gets amber. And there'll be a time when the sky is so beautiful, you turn into a poet. That is not dusk. That is nothing but twilight. As that turns into a darker shade of blue, as it turns into night, before night, that is dusk. So far, okay? No questions? Neha, done with these points?
So I
Anyone
have
else?
one.
Yeah, Hussain.
So when we travel from a lighter to a denser medium, it should bend towards normal.
It is bending away from the normal. Please remember it, remember it, remember it. Away from the normal. Away from the normal. Away from the normal. Low density to high density within a layer. Lower to higher compared from the smaller part of the layer to the central part of the layer. We are talking in-depth microscopic level of total internal refraction only right now. So please stick to it. Whatever resource material you have from where you want to justify this, share it with me.
So I'm just
Right
checking
now,
internet images.
I'm not going to take any random internet thing. So make sure you have credible sources. You should know where exactly that source has come from. So if it's Wikipedia, Wikipedia will have citations. You can check through that. Or the other source would be any related website. Simple. So share both screenshot and that, and I'll clarify your doubt. But that should not stop you from learning what I'm asking you to learn. Okay. Anyone else? Anything? Effects of ionization is still not done. Okay. You have to deal with the range, skip distance, critical angle, dead space. Only key points. So tomorrow morning, tomorrow afternoon, we have a scheduled lecture, right? So we'll continue from here. And we're going to continue write down the effect of these things on wavelength, frequency, which frequency do we use in the day and night. Generally, nighttime you'll use half of the frequency used during the daytime as a rule. So that should tell you in short, during nighttime we use lower frequencies and during daytime we use higher frequencies. This is a very important point that I'm going to write tomorrow, but I'm expressing right now for those people who are really very competitive and want more and more and more today in the present. I can only see Gulshan. Others have all gone. Huh? Done. 5:15. I was expecting you all to be ready till 5:30 for today. Tomorrow, if I say, you were not there in the last 5 minutes, I discussed it. Why are you asking me the doubt? I'm like that, right? Some doubts I'll be like that. I won't give it to you easy, right? So you'll be like, sir, I was there. Disconnection, sir. I was there. Only these good students. When I say good, it means someone who's following my instructions. Another way of being sarcastic. One day, one student was like, sir, I didn't know I'm a bad student. I don't need you anymore. Someone texted me. And I was like smiling and I was like, I have to clarify. Of course, the student has exams in a few days, right? So I said, of course, you are one of the best. Come on, it's not meant to you. And that was the truth. So I think I have to stop using words good and bad and use something else. So Atanu and all, the batch, Chaitanya, Atanu, Manan, and Hemant, Sordip a little bit, Gulshan and Hussain. Gulshan does it, but I cannot see him working today. I saw him, so not a problem. I need your videos to be on. Okay. Not every time, but get initially, tomorrow, day after, little bit. Because we are going to learn a lot of, we are going to do a lot of big budget films in a short period of time. You should know the skills. This is what we are going to do tomorrow, day after tomorrow, Sunday, Monday, Tuesday. We're going to deal with like expensive cars, you know. You have to be extra careful. You should know how to handle them. It's like I'm going to give you a suitcase full of cash. Come on. You have to be careful the way you are carrying it from here and there. So if I don't know how you are in carrying the suitcase or driving a Ferrari or maybe you're not working in a big budget film, then do you think you'll be capable of doing that? No, right? So at least I'll have the space to train you to be able to work in a big budget film or drive a Ferrari or maybe carry a bag full of cash. So that's what I need it for. So if I feel you're not ready and this is the reason why you're not ready, so I can at least help you and increase your chances of clearing as soon as you can. So to be continued. That's it from my side. Tomorrow I'm expecting you'll also talk a little more as we'll be summarizing these points. So that will give me some off time with me speaking. Or else end of the week, I get saturated with the sound of my voice. Yeah. That's it, students. No closing jokes. To be continued. Effects on frequency, maximum usable frequency, subfraction, superrefraction, and effects on the dead space, skip distance, and the relationship between the range. I think first hour should be enough to finish so that we can jump on to the next aspect. Okay. So tomorrow, let's hope we can start at least by 2:30 or 2:40 max without having to discuss and do other things. So make sure you're well revised, well read. So if you have any questions, you can discuss in the first 10 minutes. Okay, class?
Thank you,
Taking
sir.
your leave.
Bye, sir.
Thank
Bye,
you, sir.
Just a reminder to check
Bye.
my
Bye, sir.
text.
Bye.
Yeah, Hussain, tell me.
Sir, just reminding you to check WhatsApp text.
Yeah, Hussain. Reshare the message.